Okay, good evening once again. Let's have a brief review of what we discussed last time as far as linear programming is concerned, optimizing a linear problem. We said that the steps in linear programming modeling takes three basic steps. Number one is to identify the decision variables. The decision variables are those quantities that we are interested in determining. Okay, how much, how many depends on the nature of the problem. And then secondly is to identify the objective function. The objective function takes the form of either maximizing the quantity that involves your decision variables or minimizing it. So those are the two types. Of course, there's this type of mixed objectives, but we will have an example of that later on. Uh, for the next weeks, we'll just focus on a unitary objective, which is either we're maximizing something or we're minimizing something. Okay. We will, of course, be exposed to several types of problems. So far, what we have looked into is an example of a marketing problem. Okay, how many to buy? Okay, the next one that we're going to look at into is a combination of making some things and buying some things. Okay, so let me flash what we wrote last time. Okay, very sorry for this. If you can still remember this, remember that this problem that we're looking at calls for the determination of whether of the number of units of or pounds, not units, of these three products, alpha, beta, and gamma. And what we were given is the contribution margin of each per pound of the product. So we were able to assess that this is a maximization problem where we would want to maximize the
ginagawa ko.
contribution margin.
Naka-meeting.
Okay. So, mute muna kita.
Sorry po, sir.
Okay, it's okay. All right. So, then we have the contribution margin, which is maybe from your managerial accounting. You learned that the contribution margin is simply the difference between your selling price per unit divided by the variable cost per unit. And we know based on the principles of managerial accounting that if a unit has a positive contribution margin, then it's always advisable to produce or to make whatever the problem calls for that item, because a positive contribution margin entails that, as the name suggests, it contributes to the recovery of the fixed cost. Because if you take a look at the formula for contribution margin, the cost that has been subtracted from your sales is just the variable cost. And what has not been subtracted is the fixed cost. So if you have a contribution margin that's positive, then almost, well, theoretically, it makes sense to produce or to sell that product because it helps in the recovery of your fixed cost. Because fixed cost, as I said, has not been subtracted from this term, so selling price less variable cost. Okay, and then normally we will be having certain constraints as regards raw materials available, as regards maybe factory hours or machine hours or employee hours, or maybe the demand for the product. Maybe if a company has only a particular limit to, let's say we're producing perishable goods, and it might not be a good idea to produce more than what's being demanded of us because it might lead to spoilage, or it might lead to a spoilage of the inventory, so which might lead to a loss for the company. So it's very important to understand the framework or the constraints that are let's say that the company is exposed to. Okay, can you hear me, class?
Yes, sir.
Okay, sorry.
Yes, sir.
Kasi may nagsasound baka nawawala ako. Okay, because I experienced that several times. Okay, all right. So let's go back to this one. We read that through our problem, and what's important is we convert this into into equations, into mathematical expressions. Otherwise, it will remain just like this. It will remain just a text. So it's important that when we do linear programming, we have to identify the equations that's pertinent to our problem. Okay, later on we'll do nonlinear programming where the equations that are involved includes nonlinear equations. For now, we will just focus on linear expressions of the objective function of the constraints. Okay, and last time we said that in order to model our linear program, after we have identified the steps, it's important now to convert it into a template or a model that Excel will understand. Because what we're going to use for this subject, the first part is just Excel. But later on, as I said, we will either migrate to R and Python as an added feature of this subject, because it's also good to learn another software, okay, to model linear programming. Okay, the Excel already has been there for how many decades, and their solver function is very good. Okay, I can't complain because I've learned to use this. Dekada ko na rin ginagamit ng solver, and then although it can use some modifications, it can use some additional features, and usually may mga ganon through add-ins, but add-ins are usually part of software packages which you have to buy. So it's not very common for us to see an add-in for solver. I've seen some, but I don't like how they run. So maybe let's see. I'll try to see if I can still find some add-ins that will reinforce the capacity or enhance the capability of solver. As it is, okay na yung solver, no, so far. All right. So what we said was for the decision variables, we have to produce empty cells for that. So this one, we're color coding it so that it's easy for us to identify where are the decision variables here. So we have alpha, beta, gamma. Those are our products. And we are interested to determine the number of pounds to produce for these three products. And we also put here the contribution margin. It will be good, class, to design your spreadsheet in such a way that the terms that are related to each other are close to each other. Also, I also mentioned that it's also good that say constant values are set aside in a portion in your model that you can just link it to your model, okay, so that if any value changes, then you can just change this, and then automatically your model follows. Okay, instead of putting the constants in your model, especially when you're using a formula, never write a constant there. It's not a good practice as far as modeling in Excel is concerned. Okay, so we have placed here our decision variables, and then there has to be one cell for your objective function. Okay, your objective function in our case consists of the sum of the contribution margins for alpha, beta, and gamma. And then we have segregated the contribution margin for alpha, beta, and gamma. And then so we can easily multiply this to the decision variables, and then use the sum product function. Okay, we learned about the sum product, and it's more convenient rather than having to multiply this individually. So we said that this is just the same as is equal to sum product. So this is a lot easier. So you highlight the array for CM, and then highlight the array for the decision variables. Okay, so if I just type here 1, 1, and 1, you notice that we have the same answer. Okay, so it means that these two formulas are equivalent. Okay, so let me just delete this. Okay, may I ask class, could you kindly give a feedback if I'm speaking too fast or if I'm discussing too fast? I realize that this is just a review, but maybe you would want me to discuss this a bit slower, just slacken my pace a bit so that you're able to follow along. Feedback, please, guys, if I'm talking too fast or discussing this too fast. Just right. Thank you. Thank you, Erwin. How about the others? Pace is okay. Thank you. All right. In case any one of you would like me to repeat a particular portion here, please don't hesitate. Okay. We're here. This is a learning journey, and I know you're master students, and you would not want to. Nobody has ego big enough here to pretend that he knows what's being talked about, and yet he did not understand a particular portion of the lesson, not because of him, but because of how I explain. So I always look at it that way. So if there's something here that you don't understand, maybe most probably it's because of how I explained it. Okay, that's good. All right, and then we go to the let's say a relatively more difficult one to set up your constraints. Okay, in our case, the constraints are limited to the resources available, chemical A, B, and C based. There were no constraints as far as machine availability of machine hours or employee hours is concerned. So this is pretty much a very simple problem. We were told that chemical A is used by the three products, alpha, beta, and gamma, and these are the use. Okay, and we know that these are in ounces per pound. So we had to convert the usage later on. Okay, and so 4 ounces per pound of alpha, 3 ounces of chemical A for every pound of beta, and 6 ounces of chemical A for every pound of gamma. You notice how we arrange the model, our spreadsheet. It was arranged in such a way that makes it convenient for us to use the sum product. Okay, see here the sum product of this and this, right? Okay, and then the available, we were given that the available was in pounds, but since these are in ounces, we already converted it into into pounds, right? Into ounces. Okay, because let me go back to the problem. What we were given is the availability of the materials in pounds, but the usage was in ounces. So we said that for dimensional consistency, you have to check. You have to check the model. You have to check whether this side, which is what we call the left-hand side, has the same dimension as the right-hand side. So it's not possible, it's incorrect to have both sides of the equation, the left-hand side and the right-hand side, to have different dimensions. That will not work. Okay, so last time we just multiplied this. Okay, let's just check. For chemical A, we had 425 pounds, so just to review. So this was actually 425. Okay, and then multiply that by 16. That's how we get, sorry, isa dapat pala yun. No? Okay. All right, and then again, it would be good for us to have here chemical A, for example. It would have been best if those absolutes had a place here. So chemical A, B, C. Okay, let's not change. B, C, and then we also have the base, so that we can link it to this cell, to these cells here. Okay, so let's just change this. So it's 500, 425, 650, 1100. Okay, 500, 500, 425. What's the other one? What's chemical C? It's 650. Okay, 650. And then we can now link our available to, this is equal to 500 multiplied by, and maybe we can just write here conversion factor, insert. Okay, those absolutes you can conversion, okay, which is 16. Okay? And then we said that we can give these names, right? This is again by way of review. Highlight everything here. Highlight everything. Control Shift F3. Okay, I'm giving names to this absolutes by the left column. Okay. All right, then this becomes the available is equal to the available is this one, chemical A, multiplied by the conversion factor. The disadvantage of this is you cannot copy this. Okay, because if I copy this, the names will be fixed. Okay, it will still be chemical A times conversion. So let me just change this, chemical B, and then this is chemical C times conversion. The conversion is fixed, and then this is my base. Okay, if I type B, and then A, I notice that here I have the base. So I don't have actually to type everything there. Okay, so we now have this, and normally I would maybe put here a border or something just to indicate that these are constants. Okay, so any constant I usually separate so that if anything changes here, I just change the constant, and all of the all in my model, everything is linked to my constant. That way, I just have to worry about changing one thing because I know that everything is linked to the, if whenever I use these values here, I just refer to this in the model. Okay, again, the advantage of that is efficiency. Okay. All right. So once we have modeled our our LP, our linear program, our linear program, then we're ready to solve this using Excel. Okay. So just by way of quick review, we have our decision variables here. 3 decision variables, therefore 3 cells. As many decision variables, there should be as many empty cells for your decision variables. Okay. Then one objective function. We have a unitary objective function. Okay, this is not a mixed objectives, no? Or multiple objectives. We're just using one. All right, and then we have the left-hand side, okay, for your constraints, and also the right-hand side here. Okay, so here I'm just using maybe resources used, but it's always good practice also to identify the constraints. As I said, normally when you're doing a model like this, it's not only you who's going to make use of this. So it's possible that you're going to share this with others, okay, so that they understand also the model that you're doing. So let's put here available chemical A, and this is in ounces, right? And then maybe let's just copy that. Chemical B, and then chemical C. I didn't discuss this last time because I was a bit in a hurry to generate the solution. Okay, here the base is the base. Okay, so this is good model because we can see here the what this is, what these values are. Okay, and then we also color coded your objective function and also the left hand side, so that when we go to solver, it will be very easy for us to input the parameters that are required. All right, then we said that we have to go to data. and then this should be available under Analyze. If it's not available, if you were not here last time, then you will have to install this. How do you install this? You go to File, Options, and then Add-ins here. When you go to Add-ins here, okay, you will see below Manage Excel Add-ins and go. And then here you have Excel Solver Add-in. You have to click this and then OK. So once you do that, when you go to Data, the Solver Analyzer will now appear. Okay, so let's now go to Solver. Let me reset all of this so that we'll work again on this. Okay, so you have here 3 parts, and these 3 parts pertain to the 3 parts of your LP. So how convenient, okay? The objective will be your objective function, and it's either to maximize or minimize it. And sometimes you can use Solver in order to generate a solution where you want a particular value. For example, I want the objective, which is total CM, to have a value of, let's say, 1,000. So Excel will generate a solution where the contribution margin is 1,000. Just like I don't know if you have used GoalSeek. It's just like GoalSeek. But of course, Solver is much, much more powerful than GoalSeek because GoalSeek is quite simple in its formulation. Okay, so let's set our objective, which is this one. So very easy for us to determine asan yung objective natin because it's color-coded and you have the value there. And we would like to maximize that. If we were minimizing this, for example, it's a cost or another item that needs to be minimized, we just click minimize. And as I said a while ago, if we're toying with an idea where we would like to have a value of a particular value for your CM, then we can put here, for example, 1,000. Okay, then you can do this. Okay, so you can maximize, you can minimize, or obtain a solution where you have a specific value of your objective function in mind. Okay, then the changing variable cells will be your decision variables. This one. So you can see the advantage of putting it in a color-coded format. Okay, and then the constraints. The constraints, you have 2 constraints, two sets. Number 1 is your availability of your materials. Number 2 is your minimum demand, right? We said that the minimum demand has to be the units produced has to be greater than this number of units for alpha, beta, and okay. So let's now put here our constraints. So you do this by clicking the add column. And then again, you have this. Okay, you have this left-hand side and then your right-hand side. And in the middle is your operator. So it can be less than or equal to, or greater than or equal to. So you notice that for a constraint, it cannot be less than, it cannot be greater than. Okay, it has to be greater than or equal to and less than or equal to. Otherwise, you will have an unbounded solution, and that might lead to an infeasible solution. Okay, and there are 2 others here. Number 1, integer. So if your decision variables have to be integers, then you can highlight your decision variables. Let me just set that example. So on the cell reference, you put here your decision variables and then add here integer there. So it will now be part of your constraint. They have to be integers. Okay, let me just cancel that. Okay, so let me go back here, add, or it can be binary if the values are 0 or 1. We'll have examples of that. Either the solution should be integers or the solution should be binary or even all different. It's possible to have this type of a solution where, for example, in a network problem, you want to go from one place to another and you identify the routes, and you cannot pass the same route twice. For example, from Manila to from a certain part of Manila to Quiapo to whatever, right? You will not go again that route if your let's say your objective is to reach, let's say Bicol, for example. So from Manila to another part of Manila, and then you go, of course, towards you go towards the south. You don't have to go back to Manila again. And okay, so that can mean that the route should be all different. Okay, so let's go now to our problem. The cell references that we need to do, they're color coded here. So the resources that we're going to use up, this one, should not exceed the available resources. Okay, so you can see why it's very important to set your model in such a way that that well, I would say that this is solver centric, Excel solver centric, because we crafted it in such a way that it will be easy for us to translate this into Excel solver. So maybe that's the reason why we have this. That's the reason why I'm suggesting that we do this. But if we're working with another software like R, definitely this would not be needed. We just need this one. We just need these equations, and then that's what we're going to put into R or Python. All right. So that's the first set of constraints, and then we add the second. Oops, constraint must be a number. Okay. Now take a look at this. Okay. So here, all right, I placed here this one. Okay. Wait, let me change this. A while ago, okay, this one is my objective, maximize changing cells, and then let me change this. Let me just redo it because I saw an error message a while ago. So this one should be less than or equal to this one, right? That one. Let's see. If I click OK, all right. So it accept. I'm wondering why I seem to have seen an error message a while ago. All right. Let's add another one. The other constraint is that your decision variables should be greater than or equal to the minimum demand. Okay, we have to produce more than this minimum demand. Okay. All right. In case you need to add more, you can just add more here. So, for example, just for this, let's assume that the decision variable should have an integral solution. When you say integral solution, it means integers. So you cannot produce 0.5 units of alpha. They should be whole numbers. So how should you do that? You add, and then the decision variables, as I mentioned a while ago, should be int here, int, there, int, then okay, then that should already appear here, there. But since we're not imposing that this should be integers, I'll delete this. Okay, there's a disadvantage of having of inputting it even if it's not needed, which I'm going to show you in a while. All right, so we're ready now to solve this. But before we solve it, this I did not show last time, but I'm going to show it now. And we're going to do this just this once. Then afterwards, we're not going to do this. So here you have options. Okay, options. And let's click here. You have several parameters here. You have use automatic scaling. We'll have an example where we will see the importance of automatic scaling. And then here, show iteration results. Okay, so this will now generate a solution, a step-by-step solution. Now, Excel makes use of a method called simplex algorithm. Okay, simplex algorithm. There are now other methods that's more powerful than simplex algorithm. But simplex algorithm has its place in linear modeling. So we will not veer away from that. We will use this. It's a tried and tested method. But as I said, there are other methods that have been proven to be better as far as output is concerned than simplex algorithm. All right. So here you have GRG nonlinear in case you're doing nonlinear model, or evolutionary. This can be used for nonlinear. Okay, but for our purposes, we will just focus on simplex algorithm and then show iteration results. Okay. Wait. Cancel ko muna, no? Cancel. And then, by the way, I forgot to mention that oftentimes the solution should be positive. Okay, you cannot, of course, produce alpha, beta, and gamma that are negative. Okay, so how do you do that? How do you make sure that the units to be produced are positive? The one way to do that is this. So you add another constraint, and then we highlight the decision variables, and we impose that they should be greater than 0. Okay, so if we impose this, the cell references the decision variable should be greater than or equal to 0, and then okay, we are saying that this should be positive. They cannot be negative. So this is what we call the non-negativity constraint. However, okay, we don't actually need to put this, so let me delete this. Why? Because there's already here this automatic, or you can just click this. If it's not clicked, make unconstrained variables non-negative. So this is your non-negativity constraint. So there's no need to incorporate this. I'll just delete this. Delete. Okay. So I've deleted that. And then also, actually, that non-negativity constraint is redundant. Redundant means it's not needed because there are other constraints that already impose this. And watch that. This one. The decision variable should be greater than 1,500 and 400. If there's a minimum production, that's a constraint, and these minimums are greater than 0, then definitely your decision variables will be non-negative. Okay, so that's what I was saying. Although it might be a good practice to put it first and then just check whether there should be a non-negativity. Okay, because if it's not yet in the constraints, okay, but this one will really make it non-negative, because you can actually use this for a system of linear equations. Actually, you can solve a system of linear equations here. So let's say you have 5 equations and 5 unknowns in your algebra. You can use it using solver. Okay, maybe I'll show you how one of these days, but that's not really our objective. But all I can say is that solver can be used in order to solve a system of linear equations, and that, okay, in a system of linear equations, we don't impose this non-negative. I remember, if you recall in your algebra, when you're given, let's say, 3 equations and 3 unknowns, oftentimes there may be a solution with where the x or the y or the z or any of the variables are negative. Okay. All right. So enough with that. Now here, select a solving method. You have your 3 methods: GRG nonlinear, simplex, and evolutionary. For linear, it's usually simplex linear programming. This is the simplest. Okay. And then once again, let me check options, show iteration results. I'm only going to click this now. In the next problems, I'm not going to click this. Not anymore. Okay, I just want to show you something. All right. Okay. Okay, and then we solve this one. Solve. Okay. So take a look at this. Solver post. Current solution values displayed on the worksheet. So initially, solver came up with the solution, this solution, 10, 25, 500, 400, with a contribution margin of 648,750. Okay, remember this, 648,750. And then nag-pause siya, no? Kasi sabi ko, pakita niya yung show the iteration. So if I continue, solver paused again. Okay, what's next? So from 648, it became 651. And you have a different solution. Okay, so what's happening here? Solver is moving from one solution to another solution. And in simplex algorithm, what happens is that you move from one solution to a better solution. So you will not have a worse solution than A while ago, it was 648, the contribution margin. Now it's 651. The next solution, if there is, will be a higher solution than 651 because simplex algorithm makes sure that the next solution will be better. Okay, let's continue. All right. Now it's here. Solver found a solution. All constraints and optimality conditions are satisfied. Okay. Now, here you have reports. Okay, let's highlight answer report, sensitivity report. Let's skip first the limits report. We don't need that now. Okay. So answer report, sensitivity report. Okay, we can just skip solver solution or restore the original values. I'll just skip solver solution and then click OK. All right, let me pause for a while. And kindly chat, please, the chat box, if you were able to follow and generate the answer report and sensitivity report. Kindly chat, please. Feel free to ask questions, plus, if you have any. Let me just format this. Number, I'll just use a separator. Okay, 651,333. Then maybe this also. Maybe just choose one decimal place, and then separator. All right. So, okay, thank you. All right, good. Thank you so much, class. Okay, now, when we click answer report and sensitivity report, you notice that there were two spreadsheets that were added. You have answer report 1 and sensitivity report 1. Let's first take a look at the answer report 1. Okay. So what do you see here? What do you see here, class? You can see here three parts. The objective cell, okay, which pertain to our total contribution margin, right? It's E14. If we check our model, this one, our objective cell is our total contribution margin, it's E14. Okay, and it will give us the cell position E14 and D, okay, and the name of that particular cell describing the left and the top. Okay, let's show that here. This one, okay, total CM, and then CM of the product. So it takes a look at labels, most probably related to this. So CM of the products, total CM. So that's what you find here. CM of the products, total CM. It's the intersection of those rows and columns. Okay, and then the original value is 0, which is, but when we started, the contribution margin had no value. It was 0 because 0 units produced. And then the final value is 651,333. Okay, that's the contribution margin generated because we're going to produce 1,000 units of alpha, 1,000 pounds of alpha, 533 of beta, and gamma 400, giving us a contribution margin of 651,333. Okay, so back to the answer report. Okay, so this is our objective function. Okay, this one. Okay, and then we have this one, the variable cells. Okay, so what are these variable cells? These are let me increase this. These are our decision variables, which, as I said, these three steps are, okay, it's too big. These three portions here are the three parts of our model. This is the objective function, and this is the value of our total contribution margin. Okay, these are B13, C13, D13. What are they? B13, C13, D13. These are our decision variables. Okay, and if you can see here, original value again is 0, and then final value is what to produce, how many pounds of alpha, 1,000 pounds of alpha, 533 pounds of let me just put one decimal place, beta, and 400 pounds of gamma. And cont here means continuous, okay? Continuous variable, which means it can take a decimal place. Okay, that's the second portion here. And lastly, we have the constraints. Okay, let me pause. I think I have a question here. All right. Okay, sige. It's okay, it's okay. All right. Okay, let's take a look at this, class. Okay, let me just format this. Isang decimal place lang para hindi masyadong malaki yung. All right. So what are these? E18, E19, E20, E21, B13, B, C13. These are your left-hand sides. Okay, ito yung mga constraints natin. Okay, these are our left-hand sides, or if I once again flash this, ito yun. Yung mga used materials natin, no? And then ito din, our decision variable in this case is also a constraint, no? Left-hand side din siya. Alpha should be greater than or equal to 1,000, etc. All right. So you can see here 7 constraints, 4 plus 3, and that will appear in our answer report. Okay, these are your left-hand sides. Okay, and these are the formulas. There. E18 should be less than or equal to G18. B13 should be greater than or equal to B15. This is what we put in our solver. These ones. And then the value, this one, what's the cell value? This one is your left-hand side. 8,4266.67. Let me show that. 8,4266.67, etc. Okay, so we have our left-hand sides and our right-hand sides. Okay, now for the answer report, now we have here a column, bind status and slack. Now, when do you have a binding constraint? Notice that there are 3 binding here. Binding, binding, binding. Okay, can you figure out when is a constraint binding and when is a constraint not binding? Anyone? That will be important later on when we do a deeper sensitivity analysis. What's the implication if a constraint is binding? What's the implication if a constraint is not binding? Can anyone decipher when is a constraint binding? Okay, let's see. Earl, thank you. Minimum, okay. Thank you for that. Okay, partly correct, but let's reinforce that. No? Let's reinforce that. Okay, let me answer that, class. So a constraint is binding if you have a strict equality. What do I mean by strict equality? Okay, take a look at chemical A. All right, if we take a look at our model, the used resource is 8,000. The available is 8,000, di ba? So equal yung left-hand side natin at saka right-hand side natin. If we take a look at alpha, the units to produce, 1,000 to. Ang constraint natin, 1,000. So equal sila. No? All right? Si gamma din, 400 to left-hand side. Right-hand side natin, 400. So what happens now is your left-hand side is strictly equal to your right-hand side. So 3 cases ng ganon, 8,000, 8,000, 1,000 equal to 1,000, 400 equal to 400. So we have 3 cases here of binding constraint, which is your chemical A, okay, your number of pounds of alpha, your decision variable alpha, and your decision variable beta. And how are they depicted? How can we categorize them? If you subtract the right-hand side to the left-hand side or vice versa, the difference will be 0. Diba? Kaya nga, strict equality sila eh. That's why the slack is 0. So ito, tingnan nyo. So if there's strict equality, ibig sabihin yung left-hand side natin at saka is equal to the right-hand side based on the model, then you will have what we call a slack that's equal to 0. Okay? On the other hand, you have the other constraints where the left-hand side is not equal to the right-hand side. Okay? So for example, si chemical B, ang available natin 6.8, pero ang nagamit natin 4,266.7. So if you take a look at the answer report, 4,266.7 out of the, ilan yung available natin dito? Ang available natin is 6,000. Therefore, meron tayong unused na 2,533. So the difference between the available and the used is your slack. Well, at least for less than or equal to. We'll study this in greater detail kasi iba-iba ang klaseng constraint natin. No? So that the slack in this case tells us that you have excess chemicals. All right, di ba? Excess tayo ng chemical B, excess tayo ng chemical C, excess tayo ng base. Di ba? Meron tayong yung available natin is greater than the quantity that's used. And later on, this is very practical, no? Kasi, for example, should you buy more chemical C, more chemical B? Bakit? Eh may slack ka pa nga dun, di ba? From a managerial perspective, kasi ito, ang context natin ito, in fact, yung may mga, may mga case studies, yung exercise sets, na you're not only going to solve it, but you're going to write a managerial report, a managerial message or letter to, let's say, the board. So dito parang tayo, executive officers or senior officers dito. Tapos based on the solution that we generated, susulat tayo ng recommendation letter sa board. Sabihin natin, for example, na we produce this amount of alpha, beta, gamma, etc. This will give us a total contribution margin of like this. And dun sa mga resources natin, ganito. Tapos kung ano man recommendation natin, di ba? So dito pwede natin ang recommendation, bili pa tayo ng chemical A. Di ba? Kasi ang demand naman sa atin, minimum to eh. Ibig sabihin, pwede pa tayong mag-produce ng kaso naubos na si chemical A. So if there's anything here that we can suggest, it's if it's possible to buy more chemical A, hindi gamitin to. Diba? Kasi importante yan, binding constraint yan. Okay, so very particular, very important sa case ng linear programming are cases where the constraints are binding. Okay, of course, we're going to study that in greater detail. But now, suffice it to say that when you focus on especially the constraints, pay particular attention to binding constraints. Okay, these are, sabihin natin, primary citizen sila as far as candidate for analyzing them. Yung not binding kasi, so usually mga slack to, no? Imagine ito. Tapos sabihin ng staff mo, bili pa tayo ng base na na 1,000 ounces. Diba? Ang sasabihin mo, why should we buy that? Diba? Meron nga tayong slack na we have a slack of 6,000 pounds. So it doesn't make sense to buy more base. Diba? Unless may mga contravening factors. For example, ito mahirap bilhin to. Kunyari lang I'm just hypothesizing. Mahirap bilhin yan. And then for the next periods, we see that there might be a lack of base. No? So ngayon, 6,000 na lang yung natitira sa atin. So there will be a difficulty as far as acquiring this raw material is concerned. So you might, in your suggestion, provide that suggestion, that reason. Okay, but of course may basis, Hindi lang bibili ng 1,000 ng ounces ng base when in fact glaring at our face is the fact that this is a non-binding constraint with a slack of 6,000. In this case, yung mga slack dito as far as this chemicals is concerned, ito yung mga excess, no? Excess. Iba naman dito yung binding dito sa sa minimum demand, iba siya, no? Hindi excess yun, yung 33. 33.33. Yun yung well, in a sense, excess over the minimum demand. So, ibig sabihin, we were able to produce more than what was than the minimum required, 33 pounds of data. Okay, let me pause for a while and ask for questions if clear ba yung yung explanation natin so far. So far, class, clear ba yung pag-explain natin dun sa answer report natin? Okay, thank you, Erwin. How about the others, please? Okay, Rex, thank you. So let's wait for the others. They might be doing some notes. Okay, answer report. Thank you, Earl, for that question. Okay, how do you generate the answer report? Sige, let's go back to that. So we go back to this, our sheet 1. This is where we place our data. Let me delete this. No? Kasi pag hindi ko i-delete to, mangyayari sa answer report, magkakaroon ng original value. Ang original value natin, ito. No? Kasi I'm coming from this and then sinolver ko. Okay, if that's okay with you, then okay, you don't have to remove the values in the decision variables. But to replicate what we did a while ago, I'm going to delete this. Okay, so this was our original problem. And then let's go to data. And then we have here solver. So we already inputted this. Let me remove the show iteration results. Okay, sabi ko nga, pinakita ko lang yan para pakita sa inyo how simplex algorithm works. We're not going to manually solve yung simplex algorithm. Hindi yan yung objective ng course natin dito. No? Otherwise, parang naging math subject siya. Tapos, we're learning the ropes of simplex algorithm, yung array multiplication, array subtraction. Hindi yun ang objective natin. We take the role here of managers. And although we're learning how to use solver, it's with the end goal in mind na i-analyze natin siya. Kasi no one will do that for us in our case. So dapat alam natin gamitin siya, tapos kayo yung mag-generate ng output, kayo yung mag-model, generate ng output with the end goal of in mind of analyzing it. Okay? So, tinanggal ko itong show iteration results and okay. And then, okay, when you solve this, lalabas to, no? On the right side, you have your answer and sensitivity reports. I-click nyo lang yan. Okay? Click then okay. Alright? So, hindi ko na i-generate yan kasi na-generate ko na. Alright. Did that answer your question? Okay. Earl, okay. Alright. How about the others? Do you have any questions? Ara, thank you. Roby, thank you. Okay, I hope you're following, guys, on the discussion. Now, let's go now to the more difficult one. Ito na si sensitivity report. Okay, so although dalawa lang siya, no, pero mas nakaka-intimidate yung yung interpretation. Okay? So let me just copy this. I-copy natin to kasi dalawang klase ito. Control C. Kakopy ko dun sa model natin para makita natin yung relation niya sa model natin. Okay, Control V. Alright. And let me just increase the size of this. Okay. Could you please kindly take a look at your sensitivity report for our variable cells? Ano ba ito? Control C. Lagay ko dito. Okay. All right. The name is sensitivity report, diba? Sensitivity report. Okay. This is very important as far as linear programming is concerned. Okay. What does the sensitivity report answer? Diba? If I'm sure you have met that expression pag nagsi-sensitivity report tayo, we're asking that question, what if? What if? Okay, so the sensitivity report is supposed to answer the question, what if? Okay, so let's take a look at this. Okay, variable cells. So this actually refers to B13, C13, D13. Ano ba yung mga yon? Ba ito, D13, nawala yung solution ko. Bakit? Kasi tinanggal ko kanina, no? Okay, sorry about that. Okay, let me run it. Tinanggal ko pala kanina. Data solver. Okay, ira-run ko na siya. Run, solve. Pero hindi ko na i-generate tong answer sensitivity kasi meron na ako. No? So, okay. All right. So this was our solution. $1,533,400. Okay. All right. 651,333. So yung B13 natin, C13, D13, these are our decision variables. So the first part of the sensitivity analysis, let me just, bawasan ko lang decimal places nito. No? Gawin ko lang 1 decimal place para masyado kasi nag-occupy ng malaking space. No? I just reduce it to 1 decimal place. Ito din, bawasan ko. 1 decimal place lang. Okay. Alright. Then, lakihan ko nga ng ano to. I-bold ko siya para can really see it. Yan. Too big. I think it's okay. Alright. So, ito madali natin maintindihan. These are just your so decision variables, and this is the label of the decision variables. No? Number of pounds. Titingnan natin yan. Saan ang galing yan? Sa model natin. Number of pounds. Tapos sa taas, alpha. So it tries to match. No? Yung any label on the left side, the label above. So minimix lang ni Excel yan. So sabi niya, number of labels, alpha, etc. Then we have the final value. Ito alam natin to, di ba? What's this? This is your final solution. This is your optimal solution. By the way, let me just say a word about this. Itong final solution na to, class, this is the best final solution given our parameters, given our, in fact, ang ginagawa po ko pala dito, sorry, inaano ko pa to eh. Inaano ko ng border na para mas distinct siya. Yan. Medyo naka ibang border. No? All right. So this is the optimal solution. Okay, and this is the best solution that you can have given the parameters, given the constraints. And it will generate 651,333. You cannot have any other solution where the total contribution margin is greater than this. Pwedeng magkaroon ng iba pang solution, what we call alternative solution, instead of producing 1,533 and 400, pwedeng ibang quantities, pero dapat pareho lang din yung total contribution margin. Wala na tayong makikita na solution na higher than this total contribution margin. Okay, as I said, pwedeng may alternative solution in the sense that ibang units ng alpha, beta, gamma ang ipoproduce, pero the total contribution will be the same. Okay? All right. So, I hope that far we're clear, no? Sa LP na to, sa linear program na to, ito na yung best model natin, given our parameters, given our constraints, given our contribution margins, etc. Okay, so this is our final value. Okay, 1,533,400. Okay, sabi ko nga, no, pwedeng may iba to, pero dapat yung total, ito pa rin, yung total CM, objective function natin, 651,333. Okay, then we have here reduced cost, no? Ano kaya to? Then we have here objective coefficient. Ito yung contribution margin ni 350, 340, 300. Okay? And then this one, meron tayong allowable increase at saka allowable decrease. All right. So first, okay, pag-usapan natin tong ano tong mga to. Kasi importante to sa sensitivity analysis. Okay? So what are these figures? Kasi dalawang part yung sensitivity analysis, diba? This one, okay, and this one. Okay? So the first one is what we call meron tayong allowable increase and allowable decrease dito, no? And it's what we call this analysis will give us the range. Mamaya na, ito na muna. Okay, first, ano ibig sabihin tong allowable increase? So let's put here a minimum value and a maximum value. So the sensitivity analysis for our decision variables refers to your objective coefficient. Okay? So ang question dito, what if the objective coefficient changes? Okay? Kunyari ito, madagdagan to kunyari, maging 355 siya. Kasi di ba ang contribution margin ni alpha 350. Paano kung naging 355 to? Anong mangyayari sa optimal solution natin? Okay, so this sensitivity analysis takes a look at our optimal solution. Kung mabago ba yung objective function, yung objective coefficient natin, mababago ba yung optimal solution natin? Di ba ito yung optimal solution? So the question is, what will happen to the optimal solution, this one, if one of your objective coefficient changes? Okay, so take note, I'm just saying one of them. So we will first take a look at the scenario where one of them changes. No? Magbabago yung isa, and the others remain the same. Now, later on, titingnan natin yung scenario na magbabago more than one. Pwedeng dalawang pagbaguhin natin. Pero simplify muna natin, isa muna magbabago. But in order to do that, we will have to understand what the allowable increase and allowable decrease is. Okay, so we have here allowable increase and allowable decrease. So, ang ibig sabihin ng allowable decrease, pwede nating babaan yung objective coefficient natin. Kasi this is a study about the objective coefficient and how they affect the optimal solution. Okay? So we're here we're taking a look at what will happen to the optimal solution if any of this changes. Okay? Isn't that supposed to be a good question, di ba? Kunyari, sabihin natin, kung magbago yung objective coefficient, maging si 350, so sa market, hindi na tayo pwedeng lumaban ng patas sa ganito. We have to reduce the selling price. No? Kunyari, if we're going to reduce it by 10 pesos, and then the variable cost remains the same, di bababa yung ano natin, contribution margin. So what if the objective function becomes, objective coefficient for alpha becomes 340, binawasan natin kasi kailangan natin bawasan yung selling price natin to be more competitive in the market. Sabi natin, it's a buyer's market, no? Which means that maraming options yung buyers. So, if we do not compete based on price, I'm just assuming things, no? Then, matatalo tayo ng mga competitors natin. So, we have to do some price strategy, okay? And maybe offer discounts or reduce our selling price to make our product alpha more attractive. Okay, so that will be answered by the minimum value and the maximum value. Okay, so ito mas maganda class na, okay, hindi ko gusto yung ginawa ni Excel dito. Let me insert here. Ang gawin natin, ipagpalit natin, no? Si increase dito. Wala namang masama dun. No? Okay, delete natin to. Allowable decrease, allowable increase. So that, okay, mas kita natin yung ano, no, yung mas madali natin yung equation. So this is equal to, ang minimum value as far as alpha is concerned, is the existing objective coefficient, and then i-minus natin si allowable decrease. Okay? Now, ano ibig sabihin nito? 1e plus 30, this is in scientific notation. Okay, ang ibig sabihin niyan, ang ibig sabihin ng 1e plus 30, you have 0, okay, 0, and then you go to plus, ibig sabihin you go to the right. Let me show that, no? Let me type 0, and then decimal place, and then I add 30 zeros, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hanggang 30 yan. Okay, I'm not counting. Kunyari, 30 lang yan. And then, 1 there. Yan ang ibig sabihin yan. Kulang pa pala, no? Okay. Okay, anyway, kulang pa ng isang 0. No? Kaya naging negative 34 lang siya. Okay, so, ibig sabihin na nito, this is a very, very small number. No? So, practically 0 to. No? Wait, 1, sorry. Sorry, my mistake. 1, okay, 1, and then I put 35 zeros, 1, 2, 3, 4, 5, 6. My mistake. So this is a very, very big number. Okay? Sumobra ng isa, no? So, 1 and then 3, 30 zeros. 30 lang pala. So this is a very, very big number, so that minimum value kasi 350, and then I subtract this kasi allowable decrease. Decrease to eh. And then I'm going to fix this. Okay, I'm going to fix this minus. Fix pala natin. No? Remember yung pag-fix natin, F4. So we just want to fix the column E, kasi i-copy ko siyang going to the right, minus this one. Okay. And then copy down. Okay, now we have here minimum values. So ano ibig sabihin nito? Negative 1e, okay, plus 30. What does this mean? So this is a negative number, and then plus 30 zeros, negative 1, and then 30 zeros. Ibig sabihin, this is a very, very big negative number. No? We can consider it as, well, practically parang, in a sense, parang infinite na, no? Infinitely small negative. Okay, so that's what that means, no? And then on the other hand, itong maximum value naman. So it's still 350. However, we will have to add the allowable increase here. Okay, there. So ito naman, so 340 plus a very big number. So this is practically, so 340 plus a very big number will be equal to, so practically 1e plus 30 din yan. Control 1, i-ano natin yung, ito yung number, no? I-ano na lang natin as a general, okay? General lang siya. Okay, pause muna ako, class. I'm doing this, I'm discussing this deliberately kasi alam ko na medyo nakakalito din tong portion na to, no? Okay. Any questions so far, class? Okay, summarize natin, ha? Yes, Erwin?
So regarding the minimum value, for example, for product, sir, can you move it to the left?
Yeah. Okay.
For product alpha, so even if the coefficient is reduced to a negative, they will still have to, it's still optimal to produce 1,000
Yun, yung
of
titingnan natin
alpha.
ha. Tingnan natin yun ha. We're going to see that, no? Okay, so very good. Si Erwin, question na, no? Ibig sabihin ba niyan kahit na negative na yung contribution margin ni alpha, ganito pa rin yung i-produce? That's precisely the question here. Okay? So what does this mean? Ang ibig sabihin nito, class, you can change the objective coefficient. No? You can reduce it to a negative value. Okay? Negative value. Ito kasi minimum value nito, negative siya. You can reduce it to a negative value. Okay? Ceteris paribus. Ano ibig sabihin ceteris paribus? All the others being the same. So, wag natin papalitan si beta at si gamma. Ang papalitan lang natin si alpha. So, we can make this a very small number. No? Okay, tingnan natin ha. Gawin natin itong 10. Kunyari, si objective coefficient naging 10 na lang. So, let's do that. Kasi sabi dito, pwedeng negative ang minimum value. Kung maging negative siya, okay, the objective function will still be the same. Let me check baka I might have committed a mistake here sa allowable decrease and increase. But let's check, class, just to validate that. Okay, so sabi natin, si alpha kasi 350, di ba? What if this becomes, natin 10 na lang? 10 na lang siya, no? Okay, 10. So what will now be the solution? Okay, so solver ulit natin. Data, solver. Alright? So nabago na, di ba? Si alpha from 350 naging 10 na lang. Will the optimal solution change? Magbabago ba yung optimal solution? Tingnan natin Okay, solve. Alright, take a look. Solver found a solution. Okay. Look. Okay. The optimal solution remained the same. Produce pa rin ng 1,000 units pounds ng alpha, 533 ng gamma, 400 pounds ng gamma, 533 ng beta. Despite the fact that yung contribution margin nito ni alpha was just reduced to 10. Diba? However, of course, the value of the total contribution margin changed. Kasi nagbago yung contribution margin ni alpha. But ang tinitingnan natin sa sensitivity analysis ng decision variables natin is what will happen to these values, to the optimal solution, if your objective function changes. And based on the minimum and maximum value, so ibig sabihin nito, kahit na bumaba, in fact, negative to di ba? Sige, gawin natin negative. Kunyari negative to. Negative 10. Okay. So, in fact, practically, kung tutuusin, dapat kung negative yung contribution margin, kung negative yung contribution margin, it means that it will not anymore contribute to the recovery of the fixed cost. Pero tingnan natin from a linear programming perspective. Solve ulit natin to. Solver. Binago natin, no? Solver, solve. Okay, tingnan nyo. Diba? Interesting, no? Diba? Hindi nagbago yung yung optimal solution natin, yung pa rin. Nagbago yung total contribution margin natin. Okay, let me see, my question ba? Oh, yes, correct, Erwin, no? Kasi may constraint tayo di ba? Ito. And that's the reason, you're correct. That's the reason why this is a binding constraint, di ba? Sabi natin si alpha binding yan. So that's one importance of the binding constraint, which we're going to discuss in more detail. Erwin correctly pointed out, no? Kasi may minimum demand tayo. So hindi pwedeng ang bumaba to, di ba? Kaya mukhang di ba? It looks parang paradoxical na kahit pala negative yung contribution natin, margin natin. Okay. Kunyari, suppose this is a scenario where may commitment tayo dun sa isang favored na client natin. And nag-commit tayo. And failure to produce this would actually mean that losing that business. So maybe in this instance, we can only surmise, we can only cook up some scenarios, no? Na it would still be best kahit na lugi na tayo kasi contribution margin natin negative. It would still be best to produce that, no? Kasi may commitment tayo dun sa isang favored client natin na total anyway, we still have a positive contribution margin based on the beta and the gamma. But let it be now for the alpha, no? Yan natin muna mag-lose tayo dyan anyway, makaka-recover tayo sa beta at saka kay gamma. Okay? So, from face value, parang it doesn't make sense, no? Na kahit na maging ultra negative na yung ano natin, yung contribution margin natin for alpha, the optimal solution will not change still. Now let's go to the reverse. Sabi dito up to 453. So paano kung ang ano natin naging 450? 450. Okay. So kasi sabi up to 453. That's the upper bound na hindi daw magbabago yung optimal solution natin. So solver natin to. Solver, and then solve pa rin natin. Solve without generating the answer and sensitivity report. Okay. So ganun pa rin. Still the same. 453. 450 yung CM ni alpha. Still, you have the same final value. You have the same optimal solution. All right? Kasi sabi ito hanggang 453. Now, what if this becomes 460? Tingnan natin, ha? What if this becomes 460? So, lampas na yan lampas na siya ng maximum allowable increase natin dito, no? Lumampas siya 460. What will now happen to our optimal solution? Solver natin, solve. Okay, tingnan nyo, no? Nagbago na yung optimal solution. Okay? Ang iproproduce natin ng alpha, 1025. Okay? More than beta and gamma. Right? You can see now that within this lower and upper bound, your optimal solution will not change. Okay? If you change the objective function, objective coefficient, okay, within these values, then your optimal solution does not change. Assuming that only one will change. No? Okay, we will discuss paano kung si alpha nag-increase natin, si beta increase natin, si gamma increase din natin, no? What will happen kung sabay-sabay sila? Pwede ba yun? Of course, pwede yun. Pero yung analysis natin ito, okay, this is based on the assumption that ceteris paribus, no? Within this range, pag nagbago si alpha, this final value, this optimal solution holds, assuming that your beta and gamma remains the same. Hindi magbago yung objective coefficient nila. Highlight ko nga to para makikita ko kagad. Okay. All right. Let me pause for a while. Any questions so far, class? Any questions about this? Oh, let me put it in another way. Clear ba so far? Chat naman please kung clear so far. Is there anything you'd like me to repeat? Okay, good. All right. I'll suspend the discussion of this reduced cost. No? Pero let me give you a hint. Okay. Ibalik natin to sa 350. The original na natin solution. And then isolve ulit natin. So let me bring that back yung data natin. Solver natin. Okay, solve ulit natin. So our solution was, ang total CM natin, 651,333. Let me just write that here, 651,333.33. Okay. I'm not going to discuss now what does the reduced cost do. But let me just give you a hint. Okay, suppose we increase alpha by 1 peso. Yung objective function niya. Gawin natin 351. So gagawin ko tong 351. I'll make this 351. Alright? And then, isolve muna natin. Solve. Solve. Okay, what happened? What happened, guys? Nagbago ba yung solution? Hindi. Alam natin hindi magbabago kasi yung 351 is still within the, by the way, you call this class, yung solution na to, so this is called the range of optimality. It's called the range of optimality. It's that range, okay, where your optimal solution remains the same. So if you change alpha within this range, then that's the range of optimality for alpha. Then your solution, your optimal solution remains the same. The same thing for beta. We can experiment on this 77.5 hanggang kasi 3 ano si beta 340, di ba? 340. So you can decrease beta hanggang 77.5 and increase it to how much, whatever, no? Kung magkano man, kasi positive tong ano na to eh, no? Kahit magkano man yan, no? Positive, then it will not change the optimal solution. Same thing for sorry, mali, ito wala, no? We can decrease beta from 340 to 262 or increase it kahit na 1 million pa yan. Pareho lang yung optimal solution natin. Ganon din si gamma. Kahit maging negative man yan, up to 680, the optimal solution does not change. Okay, but this class, okay, sorry, this should be, lagi ko to dito ha. This is the range of optimality, no? So, ito yung range of optimality. So again, ang assumption nito, only one objective coefficient changes. Pag sabay-sabay na, iba ng rule ang gagamitin doon, no? Meron tayong tinatawag na 100% rule. Okay, so discuss lang natin next time yan kasi gusto kong abutin muna itong pangalawa, no? Okay, so what happened when we increased our alpha by 1 peso, naging 351. Nung sinolve natin siya, pareho pa rin yung di ba? Pareho pa rin yung objective optimal solution. We know that, no? Pareho pa rin yung optimal solution. But the total CM became 652,333. No? Wala natin dito. 652,333.3. Okay. So what's this? Anong kinalaman ng reduced cost? If I subtract, will this give you a meaning? Hindi siya, di ba? Iba siya, no? Iba siya. Kasi nag-increase si ano ng 1 unit, in-increase natin tong objective coefficient ng 1, 351. Kasi you might be thinking, that will be the increase, no? In your total contribution margin. Kung mag-increase si alpha ng 1. Okay? So ginawa natin tong from 350, ginawa natin 351. When we solve this, pareho pa rin yung objective natin, yung optimal solution. Our solution became, our total CM became 652,333. 652,333. Okay. Kanina, 651,333, di ba? If this was 350. Okay. 651,333. Ang ginawa natin itong 351, this became 652,333. Okay, so that does not answer this reduced cost. All right? So I will hold you guys. I will let you research anong ibig sabihin itong reduced cost na to. Itong negative 103.3 at saka itong negative 380 na to. No? In the meantime, let's go back here. Copyhin natin to. No? Ito naman, Control C, and then let's copy it here. Control V. All right. So dito, instead of yung reduced cost, meron tayong shadow price. Lakihan muna natin to. Okay. Alright. Meron din tayo ditong mga may final values din. Gawin ko lang 1 decimal place. Okay. And again, meron tayong okay. So same thing as above, meron tayong allowable increase and decrease. And same thing, let me reposition yung allowable increase natin dito sa kabila, yung decrease dito sa kabila para mas madaling maghanap ng minimum sabihin natin lower bound to or ibang ginamit natin sa taas. Call it minimum value. Sige, ito na lang din. Control C and Control V. All right. Okay, so what is this? Ano naman tong constraints dito na okay, constraints to, no? Control C, copyan lang natin. So we're looking at constraints here, control. Okay, so for this one, we're looking at, okay, ang tinitingnan natin dito, yung effect sa right-hand side natin. Yung, itong, okay. Okay. Yung natin, yung allowable chemicals, no? Yung available materials, available ingredients. So here, gawin ko lang 1 decimal place, lagyan ko lang para yung formatting niya. Okay. So constraint right-hand side, si chemical A, ang available niya, 79. Okay? So, pareho bang niya? Yeah, pareho, no? We can actually copy this formula. Okay, copy natin to. I copy the formula above. Okay, and then ito, since mga to, no? Control 1, gawin nating, general number. Okay. Yan. So I made it into a general number. Tapos gawin natin itong areal 20 para pareho yung... Okay, let's take a look at this, class. Lagyan ko ng shade to para so that we can see that masyadong Okay, so what do we find here? This, by the way, is called ito sa taas, range of optimality. Ano? Ito, Control C, copy natin to. Ito, range of feasibility. We call this range of feasibility. Okay. So what does this tell us? What do you think this tells us? Kunyari, si chemical A. Pwede ang minimum value niya is pwede siyang bumaba, 8,000 siya, no? Pwede siyang maging 7,900 or pwede siyang maging available 10,000. And what will not change? So let's do this. Let's try to figure out. Okay. So back to original na tayo, no? Okay. Back to original. Tapos what I'm going to do is I'm going to change this. Yung available magiging 8,500. Pwede ba 8,500? Ano sabi dito? Hanggang 10,000 pwede, no? So it's still within the range of feasibility. 8,500. Okay? All right. Ginawa natin si chemical A 8,500. Kanina 8,000 na yan. So ang question, what happens if the right-hand side, if the constraint, kasi constraint yung tinitingnan natin dito, no? If this constraint increases from 8,000 to 8,500. Okay, and it's within the range of feasibility, no? Kasama sa range of feasibility. Okay, so let's solve this. Let's see what will happen. So data, solver, all right? Same, everything is the same. Solve. Okay. So what happened here, class? Ano nangyari? Nung yung right-hand side ni chemical, binago natin. Okay, kasi sabi ang allowable increase 2,000. Diba? So 8,000 plus 2,000, that's 10,000. So when we increased it to a value within this range of feasibility, ginawa natin tong 8,500. Ano nangyari? What happened? What do you think, class? Yes? More resources are available. Okay. Yeah, by increasing yung yung 8,500, in-increase natin si 8,500. That means that we were increasing yung limit ni ni chemical A. Ginawa kasi kanina 8,000 lang. Pero may sinasabi to sa atin, no? Ano sinasabi itong range of feasibility nito? So from either up to 7,900 up to 10,000, what remains the same? Yun ang tanong kasi. Ano yung hindi nagbabago? Okay, medyo tricky to, no? Itong ano na to, okay, so ganito gawin natin, ha? Let's make it 8,000, 8,000. For you to see the change, let's make it 8,001. So gagawin ko tong 8,001 lang, ha? Para isang unit lang yung i-change natin. Kasi kanina 8,500, hindi siya apparent eh. Hindi natin siya makikita kagad, no? So what I did was to change this 8,001. So what will happen if chemical A, okay, if chemical A changed by, was increased by 1 ounce? Okay, iso-solver ulit natin. Wala naman tayong babaguhin sa model natin. Yun pa rin, no? Yun pa rin yung mga ano. So we can delete this. Delete lang natin to. Okay, so let's start from scratch. Tapos, anyway, alam natin yung mga values kanina, no? Ito yung mga values kanina, yung final value. At saka ito yung profit kanina, no? Ito, 651,333. Now, what happens if I change chemical A and increases it by 1? No? Solver natin, solve. Okay, same parameters. Solve. Okay, solver found the solution. All right, what happened? May napansin ba kayo, class? Of course.
Nag-increase po ng
yes,
1 yung product.
ng one, which one? Anong product?
Yung CM products po. Kasi kanina parang 650 lang siya.
Sige, tingnan natin ha. So, 651,333. Ngayon, magkano na? 651,446.67. 651,446.57. Okay. Nag-increase. Nag-increase siya. No? We would have guessed that kasi pag nag-increase avail si A, binding kasi itong A, di ba? Binding siya. So, ang binding kasi will have an impact on your objective function. So, dinagdagan natin ng 1, ano nangyari? Nagbago ba yung ano natin? Nagbago ba yung optimal solution natin? Nagbago, di ba? Kanina kasi 533.33 to eh. Pero what changed? What changed? You're right. Sabi mo, nagbago yung total contribution margin, no? Ito, naging 655,1,446.67. Okay, sige. Ano pa? Ano pa, guys? What others did you see? Did you notice? And how does that relate to this range of feasibility na to? Medyo tricky tong tong sensitivity analysis ng constraint. So binago natin yung yung right hand side natin, yung available na constraint natin, in this case yung chemical A. Ginawa natin 8,001 kasi kanina 8,000 lang yan, no? Tapos in-increase natin siya ng isa. And it's within the range of feasibility. Range of feasibility yan, 1, no? Kasi from 7,900 to 10,000, pwede yun. So, what is this range of feasibility? Okay, another example Sige. Gawin natin tong 8,010. Tingnan natin kung may makikita tayong pattern. 8,010. Alright. Is this within the range of feasibility? Yes. Diba? Kasi ang range of feasibility natin hanggang 10,000 pwede. Ini-increase lang naman natin ng 10. Okay, sige. Let's run. May sumagot ba? Okay. The range, okay, sabi ni Erwin, the range within a constraint will remain binding. Okay. So, paki-explain nga, Erwin, what you wanted to say.
Iniisip ko lang, sir, na pag halimbawa na kahit i-increase natin siya up to 10,000, siya pa rin yung magiging parang yun nga, binding, sir. Kumbaga,
Okay.
pero beyond that, ibang variable na yung magiging,
Hindi na siya
I
binding.
think. Yes, sir.
Alright.
Yun yung tingin ko.
Yeah, good observation. Tama din yun, kasi pag, say, gawin natin yung, gawin muna natin to, Erwin, thank you for that answer. Pero that's partly correct, no? But that's not what I want to point out, no? Pero tama din yung sinasabi ni Erwin na within that range, hindi nagbabago yung status niya. Binding siya si A. So ginawa natin itong 810. No? Let's see what will happen if we run this. Data, solver. Okay? And then isolve natin, solve. Okay? All right, what happened? Okay, binding pa rin siya, tama, no? 8,010, 8,000. No? Yung iba hindi pa rin binding. Binding pa rin si alpha, binding pa rin si gamma. Right? Any others that you notice? Nagbago yung composition, no? Naiba na yung ano, naiba na yung optimal solution natin, no? Hindi na pareho. Kasi kanina, ang optimal solution natin 1,533.3 tsaka 4,400. Ito iba na. 1,536 na to and 400. So, but we're not talking about the optimal solution here. Kasi ang optimal solution, tinitingnan natin dito sa variable cells yan. Doon sa range of optimality. Okay? Dito, range of feasibility. Ano kaya yung range of feasibility na yan? Record ulit natin to 652,466.67. Sulat lang natin yung mga nangyayari, no? 652 466.67. Yan ang rina-record ko, class, ha? Ito yung ito yung sa ano eh, ito yung tinatanong ko sa inyo sa reduced cost. You're supposed to figure that out, no? Ito naman, ano to? Yung range of feasibility natin. Galaw ko nga to dito. Okay, let me mag-increase lang ako dito ng ano, ha. Let me just move this a bit down. Para may konting space pa tayo na ano, na to maneuver. May napansin kayo? O, ibalik natin. Sige, ha. Anyway, naka-record naman. Gawin natin itong 10,000. Okay, sinasabi ni Erwin, no? 10,000, okay, mag-solver ulit tayo. Data, solver, solve. Okay. Let's see. 10,000 na to, no? 10,000. Tapos, what happened? Binding si chemical A. Base also became binding. Naubos na kasi si base, no? Okay? Diba? Binding pa rin si alpha, binding pa rin si gamma. Up to 10,000. What happens if this is now 10,000, 10,000, wait, dali. I-record natin to 878 para yung galaw niya 878. 878, 1, 2, 3. Naging 878, no? Yan, 878. If this became 10,010, lumampas na siya dun sa range ng feasibility, ha? Okay? Then, data, solver, alright? Run natin, solve natin. Okay? Alright. Pero dito, okay, binding pa rin siya, no? Ubus pa rin, inubos pa rin niya yung chemical A. So, it did not reach a point where beyond the range of feasibility, naging hindi na binding si chemical A. Chemical A is still binding. Okay? Alpha is now not binding. Gamma, ang binding na lang si gamma, si chemical A, at saka si base. And this became yung total CM natin, 878,616, 878,616, 0.67. 0.67. Okay. Tingnan natin class kung ano. Tingnan nga natin kung ano yung difference. Ito yung original, di ba? Ito yung original na ano na ito yung based on the base model natin. Okay, let's get the difference between is equal to this one minus this. And fix natin to. Fix natin 0, F4. Yan. I-subtract natin. Okay. Okay. May na-notice na kayo? Pinakita ko na yung answer. Andun na yung answer class. Yan. May nag-chat? Okay. Napansin ni Earl. Okay, what do you notice, Earl, sa shadow price?
Pag nagbago yung final value,
Okay.
units, yung
Alright.
shadow.
Okay, itong range of feasibility, nakalink siya dito sa shadow price. Ano si shadow price? Okay? The shadow price is the parang gradient siya, no? Parang slope siya. It's the change in your objective function. Ano yung objective function natin? Yung total CM. Per 1 unit change in your right-hand side ng specific constraint. Alright. So, ang my shadow price lang dito, lumalabas, if I increase the decimal place, ang may shadow price lang dito, yung chemical A. So, apparently, si chemical B, chemical C, and the base does not have any impact on the shadow price, no? Okay? Although may maximum and minimum value sila. Sorry, I stand corrected. Ang shadow price class is it's like a gradient, no? Gradient. In other words, parang loosely speaking, it's like a slope. It's the change in a particular variable based on a given change in a particular in a variable, no? So in our case, ang tinitingnan natin dito yung effect ng increase ni chemical A, kasi di ba 8,000 siya. So for every 1 unit increase in chemical A, dun sa right-hand side, yung available na chemical A, it will change the value of your objective function. This one, the value of our objective function is our total contribution margin ito. It will increase by 113.33 within this range of feasibility. Okay? So kunyari kung bawasan natin ng 100, okay? Bawasan natin yung 100, yung chemical A, yung available niya. Yung objective function natin, yung value natin na total contribution margin, mababawasan ng 100 times 113.33. Kasi ito per unit, no? Per unit change in your constraint. Okay? Clear yung task? Pag nag-increase o nag-decrease, ito yung change. Pag nag-increase, syempre, plus. Pag nag-decrease, ito yung mababawas per unit. Kaya nga tingnan nyo class, no? Ito, nag-1 unit change to. Diba? Ito yung 1 unit change natin. Nung nag-1 unit change, ilan yung naging effect sa objective function? 651,446, nag-increase siya ng 113.3 approximately, no? Medyo may konting difference sa price, but fractional lang. Okay? Which is quite surprising kasi alam ko dapat eksakto yan. Anyway, sige. Tapos, ito yung 10 di ba? Nag-increase tayo ng 10. Tapos ito, ano yung 226 natin? Ano yung in-increase natin dyan? Ano yung 226, Kas? Ilan yung in-increase natin sa ano? Was it ginawa nating 10,000, right? 10,000, 1, 2, 3. 10,000. Tapos pag sinolve natin to data, solve 878, no? Ito yung naging natin. So ito yung nag-increase tayo ng from 8,000 naging 10,000. We increased by 2,000, right? Tama? Class, are you with me? So, yung 2,000 na in-increase natin sa right-hand side ni chemical A, multiply that by the shadow price, okay? Multiply it by the shadow price. So there was a change of 226,667. Ito yung naging change ng objective function natin. Okay? So let me summarize. Yung sensitivity analysis natin sa constraints. Okay, so we're able to compute for the range of feasibility. So we have the minimum value and the maximum value. It tells us the range of when the shadow price is valid. Okay? So dito ang tinitingnan natin yung shadow price. When is the shadow price valid? Dito, 0. Ano ibig sabihin nito? Si chemical B, no? 6,800 siya. Kahit dagdagan pa natin ng dagdagan yan, okay? Dagdagan natin ng dagdagan yan, shadow price 0. So walang effect yan dun sa sa objective function natin. Ganon din si chemical C. Within this range of feasibility, kahit na gawin natin yung available kay chemical C, kasi ngayon 10,400, gawin natin 1 million yan. May effect ba yan sa sa shadow price na 0? Wala. And again, ililink natin sa shadow price sa objective function. Because the shadow price, as I mentioned a while ago, is a measure of a gradient. No? It is a measure of the change in your objective function for every 1 unit change in your right-hand side of a specific right-hand side. Okay? Pero tingnan natin dito, class, no? Minimum 11,600 ito. Si base. Paano kung si base natin maging 10,000 na lang? Okay? Kung 10,000 si base, up to 11,600, walang contribution to sa it will have no effect on the change in your objective function. Tingnan natin sample natin. Alright, ibalik natin sa original. So ito dapat 8,000 pa rin to. Okay, remember ceteris paribus to 1 at a time lang. No? Ito gawin natin, ano yung minimum niya? The minimum is 11,600. So gawin natin tong 11,600. 11,600. Okay, ang question, pagbabaan natin si base ng 11,600, anong effect niyan? The shadow price will be 0. It will be the same. And remember, the shadow price is linked to the impact on the objective function. Okay, so for every 1 unit change in base, okay, there will be a shadow price change in your objective function. Since it is 0, therefore, walang effect to sa value ng objective function natin. Kahit na gawin nating 11,600 si base, babaan natin. Okay, sige, babaan natin si base, class. Gawin natin, saan na yun? 11,600 na, no? Ito na. Okay. Binalik ko si chemical A, 8,000 na. No? Ito na yung original na natin, model natin. 350, 340, 300. Ayan. Alright, so solver natin. Solver. And then solve. Okay, ano nangyari, class? Binabaan natin si base, 11,600 na. Pero yung profit natin, objective function, 651,333. Ano si 651,333? Yung original. Bakit yun pa rin. Kasi nga, class, ang shadow price ni base 0. Ibig sabihin nun, ito yung factor by which your objective function value will change within this range of feasibility. Yan. Pero kung gawin natin itong 11,000, sige nga, gawin natin 11,000 si base. Okay, I'm going to make it 11,000 here. 11,000. What will now happen? Now, wala na yan sa range of feasibility, no? It's now outside the range of feasibility. I'm going to solve that. Solver. Solve natin. Okay. Nagka-problema na tayo. Could not find a solution na. Hindi na makahanap ng solution when we change it to 11,000. Eh, hindi na siya makahanap ng solution. Okay? Bakit kaya? Kasi may mga minimum demand tayo dito. No? So itong mga minimum demand na to, kailangan, in order to meet this, ang minimum requirement ng base natin 11,600. Okay? So this is one example naman na when we went below the range of feasibility, possible na hindi na magiging feasible yung solution natin. Ayun. Kaya ang tawag sa kanya din range of feasibility. So ang mga possibilities yan, mababago yung shadow price niya. Okay? That's the first one. The second one is that your feasibility will no longer exist. Hindi na tayo makahanap ng solution. Okay. So, all right, it's already time. Sabi ko 7 to 9 lang. But let me pause for a while. Are there any questions, class? I'm going to sige, bago ko stop recording. Feedback naman, please, kung if it's clear. Okay, I'm sure hindi kagad nagagrasp yung concept nitong itong range of optimality at saka range of feasibility. Kaya may I ask you to please try to solve this number 2. Itong make or buy problem na to. And then we assume in this problem that kasi wire harness to. No? So dapat integer solution to kung tutuusin. Kasi hindi ka naman pwedeng gumawa ng 11.5 na units ng wire harness. But just to simplify first our problem, okay, please, I may or may not collect, parang college. Pero please, I know you're responsible enough to please set up the what decision variables are being we are trying to solve here. What's the objective function and what are the constraints? Para next meeting, ano na lang tayo, no? We will just look at the solution so that we're able to cover more lessons. So make or buy, and then isama nyo na to, yung employment scheduling problem. So itong LP, it can be used for production problems, can be used for marketing problems, production operations, even HR problems, pwede din nating gamitin to. Maraming practical application tong linear programming. Okay, so let me pause there. Let me stop there. Are there any questions or I hope clear yung discussion natin? Clear ba so far, class? Pa-chat naman please kung you can be honest, class. Ako medyo may confusing pa. It's okay. I expect that. So that requires you to i-review nyo yung video, tas tingnan nyo ulit, no? Medyo mag-experiment kayo. Tingnan nyo kung ano nangyayari dun sa range of optimality at saka sa range of feasibility. Comments, please? Kung okay or you feel you need more time to digest. Sabi ko nga kanina, talagang medyo usually hindi talaga nakukuha kagad yung ano. But we need to study this, no? Kasi that's really part of linear programming. Comments, class? Pace is okay, thank you. Yeah, thank you for digestion. Yeah, I agree. No? Thank you, Rex, for that. Pace is okay. Yeah, thank you. Yeah. Jovial, salamat. Erwin, salamat. Okay, how about the rest? Kamusta naman? Or lost in the ano ba? Lost in, okay lang yon kung lost in the computation kayo. That's perfectly fine. That's natural, that's normal. That should not be taken against you. Clear po? Review lang ng recording kasi hindi. Okay. Thank you, Chavi. Hindi sumusunod yung Excel. Okay. Sige. All right. So thank you so much for your feedback. With that, okay, sir, sasubmit ko sa Canvas yung question number 2. Hindi muna, Rex. That's too easy for you to submit, no? Magkakaroon tayo ng mga text, ang mga case, ano, then yun ang isasubmit, no? Yung mga case studies or yung mga cases, yun ang iaano natin. Okay? Ito practice lang.
Sir,
Pero gawin nyo,
sir?
ha? Gawin nyo. Yes?
Bali yung expectation lang po for Saturday is to prepare lang po yung mga variables. Basically, setting up for discussion.
Oo. Tingnan nyo kung saan kayo mako-cover. 2, 3, 4. Kung kaya hanggang 4. Kasi I think baka kakayanin natin. Let's try to target 3 problems. Kasi next sa Saturday, dali, stop recording ko na muna. Kasi hindi na naman to part ng